Okay, so with this question here, you can see I've drawn in all the forces, okay? So you've got the weight obviously acting downwards here, and then I've resolved the weight into two directions, okay? It's important to do that because when we actually attack this question, we need to resolve parallel to the plane and perpendicular to it. Okay, so the weight is obviously going in the vertical direction, and that's no good to me. I need it. So I need the component parallel, as I said, and perpendicular. So if you mark that angle off there, which is 15 degrees, okay, so the continual of that reaction line there, right, which is perpendicular to the incline, that angle is always the same as that angle, okay, it always is. It's by the geometry of it. So when you resolve then the HG, okay, here is going to be HG cos 15, okay, because with the angle here with adjacent, and of course then the opposite of the angle is, if you look at that angle, opposite it would be this sort of direction here, opposite that angle, this direction of the triangle, okay, and this direction of course will be then this the same as this here, so the opposite is sine, isn't it? So we HG sine 15 going parallel to the plane. So it's at rest, okay? It's at rest. So what we can say is, okay, if we use Newton's second law, okay, in direction of the inclined plane, okay, and it's important to do that because that's the direction of motion, isn't it? Okay, it's the direction of motion. And one thing I could add here, even though it's not moving, is essentially the direction of acceleration is going to be that way, isn't it? Okay, because it's going to go down the hill in that direction. So that's the way it would be accelerating. But at the moment it's not moving. So what that means is when we resolve it along the direction here of the inclined plane here, then the forward force will actually equal the resistant force. We could say, look, as object is not moving, or as object is at rest, okay, you've got this Hg sine 15, which is the weight component which would be making it go down the hill. Take away then the friction, the resistance would actually equal 0. Okay, so the friction is it going to equal to, take it over to the side, 8g sine 15. Okay, so 8 times 9.8 times sine 15. So I'm looking at two decimal places. So we get 20.29. We'll go for three decimal places here because we're not we haven't answered the question yet, and we want the least possible value of coefficient of friction. Now before we do that, okay, I've resolved in the direction of the inclined plane. I need to resolve perpendicular then, okay, resolving perpendicular to the plane. Again, there's no movement perpendicular to the plane. This object will stay on the inclined plane, so it's not like jumping up or down or anything. So we've got the forces up equals forces down, so to speak, but obviously we're not thinking vertically, we're thinking sort of perpendicular to the plane here. So we've got R will equal Hg cos 15, or you could even take a bit more time. You could say, look, R take away Hg cos 15 equals 0 because there's no acceleration in that direction. So R is equal to 8g cos 15. Okay, and we can work that out. Okay, so we could do 8 times 9.8 times cos 15, and we get our answer to be 75.729. Okay, so I'm going to go for three decimal places. So then my final answer then should be fine in terms of two decimal places. It's not moving, so that means that friction, okay, as it's not moving, the friction is not necessarily at its max. Okay, so as it's not moving, friction might not be at its max. So in other words, friction could be equal to mu r or might be less than mu r. Okay, So what we do is then we put the numbers in that we know. So 20.291 will be less than or equal to mu, which is then times then the reaction, which is 75.729. And then of course then to get mu, we take that over the other side, 20.291 divide by the 75.729. Okay, so get my calculator. We get mu to be greater than or equal to 0.27 to 2 decimal places. Okay, so it's saying then what's the least value? Well, if it's greater than, it's got to be greater than or equal to this. We say the least value is going to be is 0.27. Okay, part B then. Part B says, given that the coefficient of friction is 0.1, find the acceleration of the object down the plane. Okay, so in this case now it is accelerating. So if we go back to our equations, which we had here, we just got to put in mass times acceleration. Okay, so we've got 8g sine 15. Okay, take away the friction. All right. Which will equal to mass times acceleration, which would be where's the mass? The mass is 8, isn't it? 8 kilograms times acceleration. Okay, and of course then we've got that situation going on there. We also need to resolve perpendicular to the plane, which we did before. Okay, that would still stand, right? Because it's still not moving perpendicular to the plane. So we can say, look, R is equal to 75.729. Okay, so if we go back to this one, then we can think then, go back to this, we can think, well, 8g, well that's 8 times 9.8 times sine 15. Friction, remember, is mu r. Okay, it's moving, so it's at its max mu r. The mu they said was 0.1, didn't they? And then of course in part B, mu is 0.1 times r then, which is 75.729, and that equals to 8 times a. So it's just a case then of working that out on a calculator. And we get out 12.718 equals 8 times a. So then a will equal to that answer, divide by 8, which is 1.59 meters per second squared.